Hi everyone, welcome back to Spring into Math 7. I'm Mrs. Campbell. Today we're going to be doing a review of some of the concepts we've learned so far. Let's get started. First of all, I just wanted to take a minute and review what we learned about multiplying integers. I've put the rules up for you here again. Remember, a positive times a positive is going to be a positive. A negative times a negative is going to be a positive. Remember, when the signs are the same, the answer is going to be positive. When the signs are different, like if you're multiplying a positive times a negative or a negative times a positive, then your outcome, your product is going to be negative. And I have it here in color with symbols, which seems to sometimes help. Okay, so I've also written down a few practice problems, and I thought it would be helpful to maybe go through these together. Now, you can work these any way you want, but the way that I do them is I do the math, I do the operations, do the multiplication first, and then I look at what I need to do with my sign. Is it going to be a positive or a negative result? So the first question I have is 4 times 2. Okay, so I know 4 times 2 is 8. Now I've got a negative times a negative, and we know 2 negatives create a positive, right? Remember what we said in our previous lesson about multiplying integers. 2 negatives don't make a positive in the real world, but in the math world, they actually do. All right, next problem, negative 3 times 1. Our answer for that will be 3. However, I have a negative 3 times a positive 1. I have different signs there, so my answer is going to be negative. Next one, negative 4 times negative 9. My answer will be 36. Now, is it going to be a positive or a negative? Same situation as we had in the first problem. 2 negatives give us a positive answer. And then 12 times negative 4, we know that 12 times 4 is going to be 48. And a positive times a negative is going to be a negative. All right, I also wanted to take a minute to talk about dividing integers. Remember, the rules for multiplying integers are the exact same rules for dividing integers. So once you've got them down for multiplying, you're good to go for dividing as well. I've given us a few problems to do here as well. Again, I would encourage you to do the division problem first, find the quotient, and then determine if it's going to be a positive or a negative number. And let's take a look at these. 8 minus 2 is going to be 4. I have a negative divided by a negative. I'm going to go back up here to my rules. Remember, a negative divided by a negative is going to be a positive, just like with multiplication. So that'll be positive 4. How about negative 15 divided by negative 3? So 15 divided by 3, oops, sorry about that 5 there, is going to be 5. But 2 negatives, again, my product is going to be positive. My quotient, negative 15 divided by negative 3 will be positive 5. 16 divided by 8, 2. That's an easy one. You got 2 positives. We know it's going to have a positive result. And then 50 divided by negative 5. We know that 50 divided by 5 is going to be 10. I've got different signs, though. I've got a positive divided by a negative. So my outcome will be negative 10. Okay, so quickly I want to talk about some of the properties that we use when we're multiplying rational numbers. And we've talked about these before. Remember we talked about the commutative property of addition? Well, now we're going to be talking about the commutative property of multiplication when we're multiplying rational numbers. And essentially it's the same principle, that the order doesn't affect the product. So 2 times 3 is the same thing as 3 times 2. Your outcome will still be 6 on both sides. The associative property of multiplying when we're multiplying rational numbers tells us that the grouping does not affect the product. So basically, wherever you put the parentheses around the multiplication problem, it doesn't affect the product. So let's take a look at the example I've got here. 2 times, and in parentheses I've got 3 times 4. That is the same thing as if I multiply 2 times 3 first and then 4. Both of them give me the product of 24. We also talked about the multiplicative identity, and that is any number times 1 is going to be itself. 2 times 1 is 2. Now the distributive property says if and I'll read this, the multiplication of a number and the sum of two numbers is equal to the first number times the second number plus the first number times the third number. Now, if you learn through words, that may make perfect sense to you, but I just want to show you visually with numbers what this looks like. When I'm talking about the distributive property, it helps me to see visually how it works. Take a look down here. You got 4, and then in parentheses, you've got 2 plus 3. Think of the word distribute. We're going to be distributing that 4 to both the 2 and the 3, kind of passing out the 4. So the first thing we're going to do, and this is essentially what the words in the definition say, 4 times 2, which I've got here, is the first part of the problem, and then the first part that we distribute, and then the second part is 4 times 3. So we have now distributed the 4 to both the 2 and the 3, and then we just move our plus sign over here. So the distributive property tells me that whatever happens on this side will be exactly the same as what happens on this side when I distribute the 4 to the 2 and the 3 and then add together. So let's see if that works out. So if the first way, to do it the first way, 4 times 2 plus 3 is actually 4 times 5. And what's 4 times 5? 20. And on the second side, after we've distributed the 4, we've got 4 times 2, which is 8, and 4 times 3, which is 12. What's 8 plus 12? 20. And that is how the distributive property works. Also important, I thought I'd take a minute to talk about multiplying and dividing fractions, just to make sure you were very comfortable with that. When we're multiplying fractions, it's actually super simple. All you need to do is multiply your numerators, multiply your denominators, and then simplify or reduce. The problem I've got here is 3/4 times 2/7. So I times 3 times 2 gives me 6, 4 times 7 gives me 28, and I simply reduce to 3/14. Dividing fractions is a lot like multiplying fractions, but remember, the second fraction, the fraction on the right, you're going to flip. And when I say flip, I mean you're going to multiply by the reciprocal. And let's take a look at what that looks like in an actual problem. Okay, so the problem says 24/1 divided by 3/4. All right, so the first thing we're going to do is change the division sign to a multiplication sign, and then get the reciprocal of 3/4, which is 4/3. My problem then becomes 24/1 times 4/3. And after doing the multiplication, I determine that 24 times 4 is 96, and I get 96/3. And then I simply just simplify that or change it to a whole number. And to do that, I would say, because 96/3 is clearly an improper fraction, we're going to divide 96 by 3, and I get the whole number 3. All right, guys, that just about wraps it up for this review. Thanks so much for joining us, and we'll see you next time. Bye-bye.